Move number one, if you're trying to factor, is always see if you can pull out a greatest common factor. See if you can shrink it down. So, number one, you look at the three terms, and hopefully you recognize that you can divide them all by 5. So if you were to divide them all by 5, you rewrite it as 5 times b squared 80 divided by 5 is 16, and then 315 divided by 5 is 63. So now once you've reduced it, this is not going to be too bad. If ever your a is 1, if it starts with 1, then chances are you can factor without too much stress. So what we're looking for, remember the template we did a long time ago, something that timeses and gives you the C or the 63, but it's got to add and give you the middle. So it adds and gives you B. So what two numbers times and give you 63, but at the same time will add and give you 16, and those are 9 and 7. And everything is positive, so these are both going to be positive. So then it's b plus 9 and b plus 7. And that is the factored version of this polynomial. Number two, if you look at it, this number's got to jump out at you, and this number. This is a special case. These are both perfect squares. And if they are perfect squares, then you can just do the square root. How they're timesing to get the 25n squared is 5n and 5n. And how they're timesing to get the 4 is a 2 and a 2. And now the middle will determine what the signs need to be. And since this is a minus 20, these both need to be minus. Because when you do the 5n times a minus 2, that's a minus 10n, and a minus 2 times 5n is another minus 10n. Then the minus 2 times a minus 2 is the plus 4. So that's how they're getting the minus 20n. Okay, number 3 is another special case. These are both perfect squares. You can do square root of both. But this one does not have a middle. And that's because the middle zeroes out. So what times does it give you 4k squared is 2k and 2k. What times does it give you? It's got a times to give a minus 9. So one of them is a plus 3 and the other one is a minus 3. And that's what makes it zero out. Because if you do 2 times 2k, that's 4k squared. But if you do the 2k times a minus 3, that's a minus 6k. And if you do a 3 times a 2k, that's a plus 6k. And then a 3 times a negative 3 is a minus 9. So here's where you're getting the middle to be nothing. It zeroes out. So you just got the 4k squared minus 9. Okay, number 4. If you've got 4 terms, you need to use grouping. So grouping, I'm going to group those two together, and I'm going to divide both of those by, you can just divide by 2, and they both have some k's. I can take k squared out of both of them. So if I do that, if I divide both these by 2k squared, the times problem is going to be 2k squared. That divided by 2k squared is just 7k. And that divided by 2k squared is 2. And then your other 2, these, if you group these two, you divide both of these by, since they're both negative, I'm going to take the negative out. Divide them both by a negative 3. So it's a negative 3 times 7k and a negative 3 times 2. Okay, now group 1 versus group 2. In both groups you got a 7k plus 2. So your final answer is going to be 7k plus 2. And in the other group, it's going to be these guys. So it's going to be 2k squared minus 3. And that's your answer. Okay, number 5. Okay, 5 and 13 and 6 got nothing in common. But you can take out of each of the 3 terms, they've all got a bunch of n's. So take out some n's. So if you take out n squared from each of the 3 terms, should be n squared, and what you're left with is 5n squared plus 13n plus 6. Okay, now that's as far as you can shrink it down. Your a this time, so number 1, after you divided everything by 5, your a was 1. This time your a is not 1, but it's not a special case like 2 and 3. It's not a perfect square. So if your a is not 1 and it's not a special case, you need to change this trinomial, these 3 pieces, turn them into 4 pieces. So you're going to go 5n squared plus blank plus 6. Now you do and then you're going to turn it into 4 and do grouping like we did on number 4. So if you do the very first times the very last, 5n squared times 6, that's going to be 30. 30 is our number. So 30, what's going to times and give you 30, but add and give you the middle? It's got to add and give you 13. And what times and gives you 30 and adds and gives you 13 is 10 and 3. So if I do 10n plus 3n, those will add and give me 13n. And if I times them, they will give me 30n squared. So those are the 2 numbers I'm looking for. Now once I've found them, I'm going to group them. If I group these 2 together, I'm going to divide both of these by 5n. So it's going to be 5n times n plus 2. And both of these, I'm going to divide them both by 3. So it's going to be 3 times n plus 2. And then, just like before, your final answer, group 1 and group 2 both got an n plus 2. So it's going to be n plus 2. And then your other group's going to be 5n plus 3. And that is it. Okay, number 6. Okay, you're given a quadratic equation. You got to solve it 4 ways. The first way by factoring. Okay, let's first get everything on the same side. So I'm going to move these p squareds over. So I'm going to plus 7p squared plus 7p squared. So you should end up with just 1p squared minus 6p plus 5 is equal to 0. Now to solve it by factoring, this one's going to be nice because it starts with a 1. So what times and gives you a 5 but adds and gives you the middle? And that is a 5 and a 1. But it's got to times and give you a positive 5. But it's got to add and give you a negative 6. So they both got to be negative because a negative times negative is positive, but a negative 5 plus a negative 1 is a negative 6. So when you factor it, it's going to be a p minus 5 and p minus 1. Now, what does p have to be to make these a 0? P, in this case, has got to be 5, and in this case, p has got to be 1. So 5 and 1. Okay, I'm going to get that same answer these other 3 ways. If I graph it, so graph it on the calculator. So way number 2, do it on the calculator. Let's just use what we had. Let's use 1p squared minus 6p plus 5. That's what you got to type in. That's going to be the y. So if you type that in the graphing calculator, you're looking for where it crosses the y at 0. So turn your grid on, and it's going to cross right here at 1 and right here at 5. So you get the same answers, 1 and 5. So your answers are the x-intercepts, or they are the roots, or they are the zeros. They're all the same thing. Zeros are your roots. They're your x-intercepts. Okay, way number 3. Complete the square. So if I've got the p squared minus 6p plus 5 is equal to 0. Okay, completing the square means you need to make a perfect square. You got to create one. A perfect square factors, like this will factor to be p minus 1 and p minus 5, but a perfect square is the exact same thing. P minus 1, p minus 1, or p minus 5, p minus 5, but these two are different, so they're not a perfect square. And they're not a perfect square because they gave you a c that does not work. So p squared minus 6p, you need to find the c of your own choice. There's only one c in the universe that will make this a perfect square if your b is a negative 6. So to find what makes this a perfect square, you take the b and you cut it in half. They get the middle by adding, so that must be a negative 3p plus a negative 3p. And they get the end by timesing. So remember, it's just your b divided by 2 squared. So b divided by 2 is a negative 3, and you're going to do a negative 3 times itself, and a negative 3 times a negative 3. The c we want is 9. We don't want 5. They gave us a 5. We want a 9. Now, what we're going to do with this 5, let's just move this 5 over to the other side. So let's minus 5, minus 5. So over here we got a minus 5. And if you're going to do a plus 9 on the left, you have to do a plus 9 on the right. Okay, now if you factor the left, it'll now factor to p minus 3 times p minus 3, which is a perfect square. You can just write that as p minus 3 squared. Okay, and on the right, a 9 and a minus 5, that will give you a 4. So now to solve for p, you got to undo the minus 3 and you got to undo the square. You got to undo the square first. So the inverse of a square is a square root. And if you're going to do the square root of 4, you got to give me both options. It's actually a plus or a minus 2, because those both work. And then on the left, you just got p minus 3. Now you just undo the minus 3, so plus 3, so you should have 3 plus 2 and 3 minus 2. So 3 plus 2 will give you a 5, 3 minus 2 will give you a 1. So the exact same answers over and over and over again. Okay, the last method is quadratic formula. So quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, and then we're going to use p squared minus 6p plus 5. So my a is going to be this position right here, it's 1. B is in this position, it's a minus 6, and c is the 5. So now you just plug them in. And because my answers are integers, that means this square roots should be nice, should be a perfect square. So x equals a negative b, and b is already negative, so that's actually positive, plus or minus the square root of b squared. So negative 6 times a negative 6, that's going to be positive 36, minus 4 times a times c, all divided by 2 times a. Okay, now clean up your square root. So 36 minus 4 times 1 times 5 is 20. 36 minus 20 is 16, so we're in business. 6 plus or minus square root of 16 divided by 2. So that square root of 16 is 4, so it's 6 plus 4, that's 10 divided by 2. And you got to do 6 minus 4 divided by 2, and that's 1. So these are your two answers. Okay. Find the following. Use this quadratic formula to find ABC and then AHK. So the two versions of a quadratic are standard form, which is ax squared plus bx plus c, which is what they have given to us. So the a is 1, the b is a minus 12, and the c is 27. And then the other version is vertex form, which is a x minus h squared plus k, which is the one on the right, is in vertex form. And the vertex form is easy to spot the AHK. So the a is a minus 2, the h is a minus 3, and the k is a minus 2. So the h is the one you're going to mess up on, because the h is always opposite of what it is in here, because there has to be a minus in the parentheses. So this is actually like a x minus a negative 3. So that's why it's a plus. So the h is whatever is after the minus, and after the minus is a negative 3. Okay, now the tricky part is using my ABC to find AHK. AHK, we just barely did it. It's a perfect square. So AHK vertex form is a perfect square. So if you've got x squared minus 12x, I'm going to take this 27 and I'm going to just scoot it over. I'm going to create a perfect square. So if they give me 12 for B, how they got 12 was 6 plus 6. So the C I want is 6 times 6. The C I want is 36. Because if it is 36, that will factor to x minus 6 times x minus 6, which is a perfect square, x minus 6 squared. The problem is they did not give me 36, they gave me 27. So I just scooted 27 over and I added 36. So the moment that you add 36, you need to take it right back away. You need to subtract 36. Because if you plus 36 to something and then you minus 36 to something, that's like adding 0. You were never there. So these three are going to play together and give me x minus 6 squared. These two will be like terms, and they're going to combine and give me a minus 9. Okay, now my a is right here, so my a is 1. My h is whatever is after the minus. After the minus is a positive 6, and your k is a minus 9. Okay, now the other way, if I give you AHK and you got to find ABC, all you got to do is simplify this. Let's do the exponent. Let's do x plus 3 squared. Okay, x plus 3 squared is x plus 3 times itself, x plus 3. So to get rid of the exponent, you just do that times itself. X times x is x squared. X times 3 is 3x. 3 times x is 3x. 3 times 3 is 9. But then there was a negative 2 out in front. So you got to distribute a negative 2 to all this. So negative 2 times that is a negative 2x squared. And then a negative 2 times, that's 6x. So that's going to be negative 12x. Then a negative 2 times 9 is negative 18. So that's my A. My B is a minus 12. And my C is a minus 18. Okay, let's graph this. So they're giving you a graph called f, and they want you to write an equation for g that is going to take f and slide it 2 units right and 2 units up. So you can type this in on the calculator and look at the graph and where it is, and it should look like this. So this is vertex form, so my a is a negative 2, my h is what's after the minus, so it's really a minus 3, and my k is a minus 2. So your a, you start at 0, 0. H tells you go left and right, so it's a minus 3, so you're going to go left 3. And then k is up and down, so k is going to go down 2. That's my vertex. And then your a is your slope, it's your dilation. So since it's negative 2, you're going to go down 2, over 1, and your parabola is going to look something like that. So that's the original, that's f. Now g is going to be a translation of f. So let's slide 2 units right and 2 units up. So take this over 2 units right and then 2 units up, and you should end up right there. Your new vertex is going to be like that. So the new A didn't change. I didn't change the slope. A is still negative 2. But my new H, instead of going 3 to the left, I'm only going to go 1 to the left. And my new K, I'm not going up or down, so my K is 0. So it's a negative 2 x minus a negative 1 squared. So that could be a plus, and you don't really need to put plus 0. Okay, same type of problem. Now let's do a quick sketch of this one. This tells me to go left or right, so I start at 0, and that's actually negative 2, so I'm going to go left 2, and there's no up or down, so I'm going to land right on the line. Okay, my A is negative, so it's going to be the same as last time. It's going to be negative dilation, negative slope. So there you go. Now you need to take this and reflect it over the x-axis and then translate it 4 units left. So if I reflect this over the x-axis and go more to the left, 4 more to the left, it's going to end up looking like this. So my new equation, all that I changed, a reflection, is just making a negative slope to a positive slope. So it's going to be y equals a positive 2. I didn't change the steepness. Okay, x minus, I ended up going left 6 times, so negative 6. So that's going to be plus 6. And I still didn't go up or down, so at the end is just nothing. So that should be your answer. 2 times parentheses x plus 6 squared. Okay, now on the last test, everyone did pretty good here, but they did bad here. So make sure you got good notes for how to do this if you're not given a picture. Okay, if you're given a picture, the vertex is easy to find. The vertex is right there. So the vertex is a minus 1, a minus 2. The line of symmetry is kind of that center point, what it reflects over. And that is happening at x equals a negative 1. Your y-intercept is where your parabola crosses the y-axis, so the y-intercept is right there at a negative 1. And the vertex is the low point, so it's a min. Okay, now let's start at the bottom and work up. The max or min, since A is negative, that's kind of your slope, your parabola is going to look something like that. So it's going to have a high point, it's going to have a max. The y-intercept is whatever C is, so that's easy. C is just 1. Okay, your line of symmetry, to find your line of symmetry if you're looking at an equation, it is a negative b divided by 2a. So it's going to be a negative b, a negative 8, divided by 2 times a, 2 times a negative 2, so it's going to be a negative 8, divided by a negative 4. So that is 2. That means this, your line of symmetry is happening at 2. So that's going to cut my parabola in half. So your line of symmetry is x equals negative 2. Now the vertex is just some x and some y. But you know the x is negative 2. Now we got to figure out how far up or down what the y is. So if you want to find the y, you need to take this value and substitute it in for your x's. So if you put a negative 2 in both those x's, first you got to do x squared. So negative 2 times negative 2, that's a positive 4. And a positive 4 times a negative 2, that's a negative 8. 8 times a negative 2 is a negative 16. And then plus 1. Okay, so something feels wrong. Is that right? Negative 2 squared is 4. 4 times negative 2 is negative 8. I think that is right. Okay, a negative 8 and a negative 16 is a negative 24. Plus 1 should be the y. Does the y end up at negative 23? So I think that's your vertex. Go left 2 and down 23. And that is your vertex. Oh, that's what's wrong. Okay, I'm an idiot. It's not a negative 2. How come I put x as a negative 2? Your line of symmetry is over here at a positive 2. Your x is a positive 2. That's going to change everything. Alright. So if your x is not a negative 2, your x should be a positive 2. Because your line of symmetry, I don't know why I got a negative there, is at a negative 8 divided by a negative 4, which is positive 2. So now I'm plugging a positive 2 into there. So positive 2 times 2 is 4 times negative 2. That's still negative 8. But a positive 2 times 8 is positive 16. So a negative 8 and a positive 16 is just 8. And 8 plus 1 is 9. There we go. That's better. So your vertex happens over 2, up 9. Alright. Okay. Look at the parabola to find ABC and AHK. Okay, your A is your slope. And on the test, I will give you the slope. Your slope is from the vertex is to your next point. But your slope is changing as time goes on. It's getting steeper and steeper. So you can only do the first point from the vertex, which is 1 over 1. Rise over run. It's positive, so A is 1. Okay, now this is my H. So from 0, I go left 2, so my H is negative 2, and down 3, so my K is negative 3. To find B and C, C is your y-intercept, which is right there, so C is 1. But B is hard to find, so here's how we got to find B. I'm going to take my A, H, and K. It's going to be y equals 1, parentheses, x minus h, which is a minus 2, squared, plus k, which is a minus 3. Okay, now this is a plus. And to find my ABC, I'm just going to simplify this. So I'm going to times x plus 2 by itself. So it's going to be x plus 2 times x plus 2, which is going to be x squared plus 2x plus 2x plus 4. So x squared plus 4x plus 4, and then minus 3. Because I got to distribute 1 to everything, but that's not going to do anything. So a minus 3 and a plus 4, your final answer, x squared plus 4x plus 1. So my A is 1, my B is 4, and my C is 1. So my B ends up being 4. Very good. Next. Okay. We're going backwards, so look at this guy. If I give you x squared minus 2x minus 35 equals 0. So quadratic, and since it starts with 1, hopefully it's going to factor easy. And let's say factor this and find the zeros. Solve for x. So if you factor this, what times this gives you a minus 35, but adds and gives you a minus 2. And that is a minus 7 and a plus 5. So that'll factor to x minus 7 times x plus 5. So your answers are what makes these two quantities 0. Because I need to end up with a 0. So what's going to make my first group a 0? X equals 7. And what's going to make my second group a 0? X equals a minus 5. So these are my zeros. X is 7, X is minus 5. Okay, now look, A, I'm giving you the zeros. I'm giving you the roots. So you've got to go from the answer, 1 step back, 2 steps back. I need this. So if you have the answer 1 step back, I need these. So it's going to be x and x. 3 into this group is going to make a 0. So this group needs to be x minus 3. Because if I put 3 in for x, 3 subtract 3 is 0. 7 is going to make this group a 0, so it's got to be x minus 7. Okay, now I'm just going to distribute x times x squared, x times a minus 7, minus 7x, a minus 3 times x is minus 3x, and a minus 3 times a minus 7 is a plus 21. So it's x squared minus 10x plus 21 is 0. Okay, now b, I'm going to go backwards. X and x, 0. What will make this is 0? Just nothing really. Because if I put 0 for there, so I don't got to put anything there. Now minus 2. If I put a minus 2 in there, this has to be plus 2. Because minus 2 plus 2, there's my 0. So I'm just going to times x to the x to get x squared, and x to the 2 to get 2x. And there's your equation. X squared plus 2x equals 0. Okay, C. So look at A. Your zeros are at 3 and 7. So 1, 2, 3. There's a 0. 4, 5, 6, 7. There's a 0. Your parabola looks like this. B, 0 and a minus 2. So there's 0. Here's a minus 2. Your parabola looks like this. C is a little different. C over here at 7, your parabola is going to look like this. So if you only have 1, 0, that means that is happening at the vertex. It's not crossing down below and then turn around and coming back up. It just hits right there and then turns around and goes. So your 0 is 7. It's going to look like this. You're still going to have 2 groups, but it's going to be the same in both groups. So this is a perfect square. So it's going to be minus 7 and minus 7. So anything that's a perfect square is happening at the vertex. So it only has really 1 crossing. So here we go. X times x is x squared. X times a minus 7 is a minus 7x. Minus 7 times x is another minus 7x. And that's a plus 49. So your equation is going to be x squared minus 14x plus 49 equals 0. Next. Okay, 3 quadratic equations. You got to solve them. Now they're designed. One's easy, one's medium, one's hard. So first move in any quadratic because you got to get everything on the same side. So move this over. Move this over. So you should. I'm going to change them to x's. X squared. 16 take away 7 is 9x's. And then 27 take away 7 is 20. Okay, this one's easy. It's easy. The hint is it starts with a 1. If it starts with a 1, I'm going to try and factor it. So I'm looking for what times this and give me 20, adds and gives me 9, and that's 4 and 5, and it's all positive, so the signs are all positive. I can hear Brock. Here comes Brock. Alright, so it's going to be x plus 4 and x plus 5. So that means my zeros are going to happen at a negative 4 and a negative 5. Not too bad. So let's try the middle one. Alright, the middle one. So I'm going to move this over. Plus 3r, plus 3r. Alright, here's Brock. I got to pause it.